Here we're going to go ahead and talk about the product and quotient rules just by themselves. So the product rule is when we want to take the derivative of f of x times g of x, so two functions multiply by each other. And that rule means that I'm going to take the derivative of f of x, multiply it by g of x, and then add it to f of x times the derivative of g of x. And first of all, we're going to see if this rule works in general. So we're going to see how this whole thing works. So we're going to go ahead and compute the derivative of 3x squared times parentheses 2x plus 1. So we're going to consider 3x squared to be our f of x and our 2x plus 1 to be our g of x. And we're going to go ahead and compute the derivative using our product rule. And then later on, we're going to go ahead and check it a different way. So with our product rule, the derivative of 3x squared is 6x. We take the 2 multiplied by 3, have x, and we're going to multiply that by g of x as it is, so 2x plus 1. We're going to add it to f of x as it is, so 3x squared, and the derivative of g of x, which is just 2. And we're going to go ahead and multiply that through. So we're going to multiply f of x through g of x for the first piece. We're going to have 12x squared plus 6x plus 6x squared. All right. And this plus 6x squared is going to be just the g of x times f of x. And when we go ahead and combine like terms, we end up with 18x squared plus 6x. Now we're like, well, okay, why are we trying to do this? Like, is there another way to do it? Of course there is. So we're going to go ahead and try to go ahead and compute the derivative using the power rule only. And first of all, we need to go ahead and take our f of x and multiply it by g of x first. Okay, so when we go ahead and do that, we have the 3x squared, and we have to distribute it through the 2x plus 1. And we end up with 6x cubed plus 3x squared. Okay, no problem. Now if we want to go ahead and take the derivative of this, we go ahead and use our rule for it. So the 3 and the 6 are going to multiply. We get 18x squared. And then the 2 times the 3 minus 1 on the exponent is plus 6x. And you'll notice that this answer matches the answer we got using the product rule. Now, the reason why the product rule actually exists is sometimes we can't multiply the terms out from the original function, just like we did here, or it is too cumbersome to do so. It's some crazy polynomial function, let's say a trinomial times a trinomial, and it can get really involved. So in this case, we want to go ahead and rely just specifically on the product rule. Right, so we want to go ahead and calculate the derivative, and here we're not going to expand our answers or simplify the result or anything. We just want to go ahead and compute this. So here we're going to start off with our f of x is going to be 2x squared plus 4x minus 5, so a trinomial. And then our g of x is going to be x minus x to the negative 1 power. So here we've got something a little unique going on. All right, and what we're going to do is we're going to use strictly our product rule. And we're going to take the derivative of our f of x. So our derivative of our f of x is just going to be 4x plus 4. We're going to multiply it by our g of x, x minus x to the negative 1 power. And we're going to add it to our f of x. So we have our polynomial 2x squared plus 4x minus 5. And then the derivative of our g of x, which is just 1 plus x to the negative 2 power. Notice we didn't try to convert this to a fraction or anything like that. All right. And then let's look at this one here. So here we have y is equal to x to the 0.7 power minus 4x minus 5 times x to the negative first minus x to the negative second. And if you haven't noticed from your homework so far, a lot of times we end up with these really weird exponents, or our bases are not necessarily whole numbers, right? So here we're going to go ahead, take the derivative of our f of x, which is our first term, and we have 0.7x to the negative 0.3 power, because remember, you got to subtract 1 from that 0.7, so that's going to leave you a negative value. And then from our 4x minus 4. All right, and they're going to multiply it by our g of x, which stays the same, x to the negative first power minus x to the negative second. We're going to add that to our f of x as it is, so x to the 0.7 minus 4x minus 5 times the derivative of our g of x, so we have a negative x to the negative 2 power plus 2x to the negative third power. And notice we're not simplifying either one of these. We're leaving them exactly as they are. Okay, and now that we have looked at the product rule, let's go ahead and look at the quotient rule. So the quotient rule is when we want to take the derivative of some function f of x divided by some function g of x. And that's going to be very similar to the product rule with a little bit of a twist. So we're going to take the derivative of f of x times g of x, and we're going to subtract the derivative of g of x times f of x. And then we're going to take that whole thing and divide it by g of x squared. All right? So just similar but slightly different. And so we're going to go ahead and take a simple example here, and we're going to go ahead and compute the derivative. So we're going to take an example of y is equal to 3x minus 9 divided by 2x plus 1. So 3x minus 9 is our top function, or our f of x. And our 2x plus 1 is going to be our bottom function, which is our g of x. Okay? So the first thing we're going to do is we're going to go ahead and take the derivative of our f of x, or our top function, which is just going to be 3. And we're going to multiply that by our g of x, which is 2x plus 1. We're going to go ahead and subtract the derivative of the bottom function, so the 2x plus 1, which is just 2. And we're going to go ahead and multiply that by our f of x, which is 3x minus 9. And we're going to take that whole thing and we're going to go ahead and divide it by g of x, our 2x plus 1, the whole thing squared. All right. And without going ahead and taking care of the bottom squared, we're going to go ahead and distribute through the top. And we're going to go ahead and end up with 6x plus 3 from our top part, and minus 6x plus 18 from the second part of our top part. So we got the whole top distributed out. And we notice that our 6x's cancel out. One is positive and one is negative. So we're going to go ahead and cancel those two out. And we end up with just 3 plus 18, which is just 21, over our 2x plus 1 squared. And this does not simplify even if we wanted to, so we're going to leave it exactly as it is. Let's go ahead and look at a different one. So here we're going to go ahead and take a trinomial. Then we have 3x squared minus 9x plus 11. And that's going to be our top. And we're going to divide it by 2x plus 4, which is our g of x, or our bottom function. All right. So taking the derivative of f of x, we end up with 6x minus 9. And we're going to go ahead and multiply that by our 2x plus 4, which is our bottom function, or our g of x. And then we're going to go ahead and subtract. Now, our derivative of g of x is just going to be 2. And then we're going to multiply that by our 3x squared minus 9x plus 11, which is our f of x. And then we're going to divide that whole thing by 2x plus 4 quantity squared. And again, we're not going to touch that bottom function yet. And we're going to worry about everything on the top and try to simplify it as best we can. So when we go ahead and distribute the first piece of our f of x prime, and our g of x, or derivative of f of x times g of x, we have to FOIL that. And we're going to end up with 12x squared plus 24x minus 18x minus 36. And then we're going to go ahead and distribute the 2 through the trinomial. So our g prime of x times our f of x. You're going to end up with negative 6x squared plus 18x minus 22. And the first thing we're going to see what happens is our 18x's our opposite signs, and they're going to go ahead and cancel. And we have a negative 6x squared we're going to combine with our 12x squared. And that ends up with a positive 6x squared. We have a positive 24x, and then our negative 36 minus minus 22 is going to give us a negative 58. And that's going to be over our 2x plus 4 quantity squared. And what I'm going to go ahead and do is I'm going to go ahead and factor out from the top and bottom. And we're going to go ahead and pull out a 2 from the top. And we're going to pull a 2 squared or a 4 out of the bottom. Because remember, these things have to be squared. And so we're going to go ahead and cancel out the 2 and the 4. And we're going to be left with our trinomial on the top, 3x squared plus 12x minus 29. And then we're also going to end up with a 2 times quantity x plus 2 squared in the denominator. Now, if you do not see the 2 squared pulling out to make that cancel with the top, at that point you can go ahead, FOIL the denominator, and pull out the GCF, and you're going to see this actually works out to be the exact same thing. So if you do not see the 2 squared or the 4 to be pulled out from binomial squared, feel free to go ahead and FOIL that out, pull out the GCF, and you're going to see that whole thing cancels out exactly as you think it should. All right, let's go ahead and look at our final example. So we're going to go ahead and compute the derivative of x squared plus 9x minus 1 divided by x squared plus 2x minus 1. So here again, we have to go ahead and do our derivatives of each piece. So on my top, again, is going to be f of x. My bottom is going to be g of x. When I go ahead and take the derivative of f of x, I end up with 2x plus 9. I have to multiply that by my trinomial on my g of x, and then I'm going to subtract. Now I have to go ahead and take the derivative of my bottom function, so it's going to be 2x plus 2. And I'm going to go ahead and have to multiply that through my trinomial of my f of x. And then, of course, my g of x, my bottom function, has to be squared. And here I have to do a lot of distributing. And so I'm going to end up with 2x cubed plus 4x squared minus 2x plus 9x squared plus 8x minus 9 for my first distribution. And then I'm going to go ahead and subtract. And remember, when I subtract, I have to go ahead and change all my signs. I have 2x cubed minus 8x squared plus 2x minus 2x squared minus 18x plus 2. What I have to go ahead and do is cancel out terms that are identical. So my 2x cubes cancel out. My 2x's cancel out. And I have an 18x that also cancels out. And then I just combine everything that's left over. And that ends up being negative 7x squared minus 7 divided by my g of x, x squared plus 2x minus 1 quantity squared. And I can go ahead and leave this alone because there's no way we'll be able to simplify this fraction any further.